You are welcome to this session of vector calculus. In the previous session, we looked at the dot product of two vectors. Today, we're going to look at the cross product of two vectors. Cross product of two vectors. And another name for cross product, because the resultant product is a vector, we also call it vector product. Vector product. So we use cross product to find the angle between two vectors and also find the torque of vectors. And so by definition, if you have two vectors, A, which is made up of A1, A2, A3, and B, which is made up of B1, B2, B3, then by definition, the cross product of these two vectors, denoted as A cross B, can be written as a vector which is made up of A2, B3 minus A3, B2. That's for the I component. Then for the J component, we are going to have A3, B1, A3, B1 minus A2, B3. That's for the J component. And then we have for the last one, which is the K component, we're going to have A1, B2 minus A2, B1. So this is the vector. This is the vector of A cross B. This is what we get. But to memorize this formula, it's become very, very cumbersome. So we're going to use another approach in finding the cross product of these two vectors. And by way of doing that, we use the determinant of a 3x3 matrix. Until we all know from Maths 1 how to find a determinant of 3x3 matrix. So let's use that. So if we want to find the cross product of these two vectors, we use the determinant I, J, K. Then we have the A component, which is A1, A2, A3. Then B component B1, B2, B3. And then, so what we know the sign table when you are using determinant. So the first one is plus, minus, plus, minus, plus, minus, plus, minus, plus. So what we do is that the first component I, we cross the i's. We are left with what? A2, A3, B2, B3, and then times I. Since the sign here is negative, we're going to have negative. Then we cross this one, we cross this one. So we're going to have A1, A3, B1, B3, all times J, and the last one plus K. The K component we cross here, we cross here. So we're going to have A1, A2, B1, B2 times K. Right? So when we manipulate it, we're going to have this a determinant, this is a 2x2 determinant. So we all know how to calculate determinant of a 2x2 matrix. So that one will be A2, B3 minus A3, B2 I component minus A1, B3 minus A3, B1, and then J plus the last one, A1, B2 minus A2, B1. So A1, B2 minus A2, B1 times K. So we need to manipulate with the negative. When we open the brackets because of the negative, we're going to have A2, B3 minus A3, B2 I in the I direction. Then we're going to have plus, minus times minus is positive. So we have A3, B1 minus A1, B3, all in the J direction, plus we'll have A1, B2 minus A2, A2 B minus A1 B2 minus A2. This is B1, A2 B1. Sorry for the mishap. And so if you look at what we have arrived at and compare it with what we wrote, then this corresponds with this one corresponds to this, and this one corresponds with that. We see that after using the determinant, it becomes very easy. So we're going to have A2B3 minus A3B2I plus A3B1 minus A1B3J. And if you compare with this, you see this one is easier. And because of how to memorize this formula, there's a tendency that you can make a slight mistake. So instead of B2 here, this subscript should be A1. And so the determinant method makes it very easy so that you don't miss any term. So for the J column, we're going to have A3B1 minus A1B3, A3B1 minus A1B3. Then the K component will be A1B2 minus A2B1. And that is what we have. So we'll take an example and see how we can calculate the cross product of two vectors so that we can all understand with live this figure. So let's take, for example, let's quickly take this one off and take an example where, for example, where we're asked to calculate cross product of two vectors, which is vector A, which is minus 3, 2, 5, and then vector B, which is giving us 1, minus 4, 3. And so using the determinant method, then A cross B now becomes I, J, K, vectors I, J, K. Then since A comes first, we're going to use write the components of A. So we're going to have minus 3, 2, 5, and then the last one will be the component B, and B will be 1, negative 4, 3. And so using the same method for the I component, we cross here, we cross here. So we're going to have determinant 2, 5, negative 4, 3, and that is for I component, minus the determinant for the J, where we cross here, we're going to have 2 by 2 determinant, minus 3, 5, 1, and 3. And then that is for J. And the last one will be K, where we'll cross the horizontal and vertical. We're going to have minus 3, 2, 1, negative 4 times K. So when we find the determinant of this 2 by 2 matrix, we're going to have 2 times 3 with 6, negative times minus 5 times negative 4. Negative become positive. So 5, 4, 20, right? I. Then our minus is still here. They're going to calculate the determinant. Negative 3 times 3 is negative 9. Then minus 1 times 5 is 5. It's J plus determinant. Negative 3 times negative 4 will give us 12. Then minus 1 times 2 will give us 2. So in conclusion, we're going to have 26I. Then minus 9 minus 5 is minus 14 times minus plus 14J. And then plus 10K. So this is the cross product of two vectors. And we can see from the answer that the cross product of two vectors still remains a vector. And you know, every vector we learn from beginning. Every vector has the magnitude. We can always calculate the magnitude of this vector. So I hope we've been able to explain it, and you've been able to learn the formula. So to recap, we're going to use a determinant formula in calculating the cross product of two vectors. And so, taking this as an example, we've been able to calculate the cross product of this vector, and that gave us 26i plus 14j plus 10k. Thank you very much for your attention.